Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 3 video on the chapter of playing with numbers, where I will discuss about the tests of divisibility of numbers by numbers from 2 to 11, and will solve some selected problems from the exercise 5b of the textbook of author RS Aggarwal. And in the next video, I will solve more illustrative problems on this topic, that is tests of divisibility. From those problems will be a little harder, taken from some other sources. So in this video, I will only solve the selected problems from exercise 5b of author RS Aggarwal. So this video is part of the playlist CBSE Maths for Class 8, following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, or if you are watching my videos and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my quick notes on the topic of tests of divisibility on the left hand side, and on the right hand side I will do the discussion and solve the problems of exercise 5b. I hope the quick notes is visible so that you can read it properly. The fonts are large enough. Okay. Now, we have tests of divisibility is about checking whether a given number is divisible by the digits like 2, 3, 4, 5, 6, 7, 8, 9, and the numbers 10 and 11. So we will check the divisibility by the numbers 2 to 11 of a given number. So without any loss of generality, let's assume that the given number is a 4-digit number, XYZW, XYZW. So definitely XY, all these XYZW are the digits. XYZW are digits. That is, all of them are greater than equals to 1. All of them are greater than equals to 1 and less than equals to 9, since they are the digits. No, sorry, they are greater than equals to 0 and less than equals to 9. Okay. Now, the reason that I have considered a 4-digit number because of for the discussion of divisibility by 4 and 8. To check the divisibility of a number by 8, we need at least 3 digits. We need at least 3 digits. So that is the reason I have taken 4 digits. Now, I could have also taken 3 digits, but it is better if we take 4 or 5 digits as the number to discuss the rules of the divisibility tests. Okay, so first one is, let me quickly check if everything is visible or not. Okay, so these are the rules that apply for a given number. Let's say we are considering a 4-digit number XYZW. Whether this number will be divisible by the numbers 2 to 11. So first one is divisibility by 2. So the number XYZW, any number, will be divisible by 2 if the digit at the units place or ones place is an even digit. Is an even digit, that is, it could be 0, it could be 2, it could be 4, 6 or 8. That is any digit divisible by 2, that is an even digit. So for 1, the number is XYZW. So this, the digit at the units place or ones place is W. So that has to be an even digit. Then the whole number will be divisible by 2. So this W can be 0, 2, 4, 6 and 8. Okay, so this was pretty simple. 2. Divisibility by 3. Now, divisibility by 3 is that the sum of all the digits of a given number must be divisible by 3. Then only we can say that the given number is divisible by 3. So, since we are considering the given number to be a 4-digit number x, y, z, w, we must have the sum of the digits will be x plus y plus z plus w must be, this number must be divisible by 3. Okay, so this was also all the rules are pretty simple except for 7 and 11. Except for 7 and 11, it is a little complex, but otherwise the other numbers 2 to 11 except 7 and 11, they are pretty straightforward. So a number will be divisible by 3 if the sum of the digits of the number is divisible by 3. So I have not provided any example in the notes. Also, I will not explain the concepts with any examples because it is pretty straightforward. It will be clear when I will solve the problems of exercise 5b. The next one is divisibility by 9. The same rule applies as for 3. A number, that is the number x, y, z, w will be divisible by 9 if the sum of the digits, that is x plus y plus z plus w, is divisible by 9. Now, is divisible by 9. Okay. Now, one thing to note regarding the divisibility by 3 and 9 is that if you see any number divisible by 3, it will not mean that it is divisible by 9 as well. But if a number is divisible by 9, it will obviously also mean that it is also divisible by 3 because 9 is nothing but 3 into 3. So this thing you must keep in mind. Okay. Number 4 is divisibility by. So divisibility by 4. So any number will be divisible by 4 if the number formed by the last 2 digits is divisible by 4. So in our discussion, the number we have taken we have assumed to be x, y, z, w, a 4-digit number. So this number it could be 5 digit, 6 digit, whatever. The last two digits, the number formed by the last 2 digits, that is zw, must be divisible by 4. Then only the whole number, that is x, y, z, w, will be divisible by 4. Okay. Divisibility by 8 is the same concept like divisibility by 4, but in this case, if we have to consider the last 3 digits, the number we have assumed is x, y, z, w, and the number formed by the last 3 digits is y, z, w. So this number must be divisible by 8. Then we can say that the whole number x, y, z, w is divisible by 8. Okay. Now, regarding the divisibility of 4 and 8, you must also keep in mind, just as I discussed for divisibility by 3 and 9, if a number is divisible by 4, it does not mean that it will be divisible by 8. For example, 4 is divisible by 4, but 4 is not divisible by 8. 12 is divisible by 4, 12 is not divisible by 8. So if a number is divisible by 4, it does not mean that it will also be divisible by 8. On the other hand, if a number is divisible by 8, it will also mean that it is also divisible by 4, because 8 is nothing but 4 into 2. Okay. Now comes the divisibility of 6. Now divisibility of 6 is saying that a number, the xyz, w, the given number will be divisible by 6 only if it is divisible by both 2 and 3. The number has to be divisible by both 2 and 3. Only then we can say it is divisible by uh, it is divisible by 6 is, I'm not writing anything new, it is already written in the quick notes, is divisible by both 2 and 3. Okay. Now divisibility by 7. Now the quick notes might be a little confusing, but the idea is that how do you check whether a given number is divisible by 7 or not? The idea is, since we are considering a four-digit number, the idea is you take the digit at the units place or ones place, which is W. You take twice the digit, two times the digit at the units place, which will be in our case 2W. You subtract that from the number formed by the remaining digits. This is the number formed by the digits excluding the units digit. The number, original number was XYZW. The digit at the units place is W. If you exclude the W, the number formed by the remaining digits is XYZ. So if you subtract twice of the units digit, that is 2W, from the number formed by excluding the units digit, that is XYZ, this value has to be divisible by 7. If this number is divisible by 7, then you can say that the original number XYZW will be divisible by 7. Now, in the notes, you might be confused by the fact that XYZ minus 2W. Now XYZ could XYZ is a three-digit number. It for a larger digit number. So all these examples in the quick notes, all the rules are based on the fact that the given input number is a four-digit number XYZW. Now, if the number was X, Y, Z, W, U, V, let's say the given number was three-digit number XYZ, W, U, V, then how will you check whether this number is divisible by 7 or not? So the digit at the units place is V, and the number formed by the remaining digits is X, Y, Z, W, U. So we subtract twice the units digit, that is twice V, from the number formed by the digits excluding the units digit, which is the number X, Y, Z, W, U. Now if this value is divisible by 7, will imply that X, Y, Z, W, U, V is divisible by 7. I hope you got the concept. Okay. 8, divisibility by 10. This is pretty straightforward. Any number which is ending with a 0, ends with a 0, will always be divisible by 10. So in our case, since we have considered the given number to be a four-digit number XYZW, the digit at the units place or tens place is W. So W has to be equal to 0. If W is 0, then it is obvious that this number will be divisible by 10. Okay. 9, divisibility by 5. For divisibility by 5, the digit at the units place has to be either 5 or 0. It is also a straightforward rule. The given number is XYZW, so W is 0 or 5. If W is 0 or 5, then we can say that the number XYZW is divisible by 5. Okay. Now divisibility by 11. Divisibility by 11. Okay. The idea is that, so we are having the number, we are considering a four-digit number. So my handwriting has started to become very crazy because my machine is running very slow. I'm sorry for that. So the given number is x, y, z, z, w. The idea is that you take if the concept is this number, any number of digits will be divisible by 11 if the sum of digits at odd places means you can consider from the left hand side places first place, third place, fifth place, these are the odd places, and the even places are second place, fourth place, like this. Sum of digits at odd places minus sum of digits at even places. This whole number value is either 0 or divisible by 11. Then we can say if this value that is the difference of sum of digits at odd places and sum of digits at even places is either 0 or it is divisible by 11, then we can say the number, that is x, y, z, w, is divisible by 11. So in this case, if the number is the 4-digit number x, y, z, w, it will imply that x, the digits at the odd places are x and z. So x plus z minus the digits at the even places are y and w. So this value is equal to 0 or it is divisible by 11. Then we can say that the number x, y, z, w is divisible by 11. Now to give you an example, a little different example, let's say the number is given number is ABCD, where ABCD, A, B, C, D, F, let's say G and H. So it's a 8-digit number. It's an 8-digit number where ABCD, E, F, G, H are all digits, that is 0 to 9. Now this number will be divisible by 11 if we take the sum of the digits at the odds places, that is A plus C plus E plus G, and then we subtract the sum of the digits at the even places, that is B plus D plus F plus H. So this is equal to 0 or divisible by 11. Then we can say that the 8-digit number ABCD, E, F, G, H will be divisible by 11. So that was all regarding the rules that apply for test of divisibility by the numbers 2 to 11 of a given number. Some are very straightforward. A little complex could be the 7, divisibility by 7 and 11. 11 still it's very simple. If you practice a lot of problems, you will get used to it, the rule. And 7 also, with practice of problems, these are will not be any issue. Okay. So there is really nothing much to talk about the tests of divisibility. You just need to know the rules that applies for the test of divisibility of the different numbers, that is 2 to 11. Now let's solve the problems of exercise 5b. Let me quickly check. Okay, I hope the exercise 5b problems are visible on the left hand side. I will not solve all the problems. Definitely there are redundant problems, but I will solve few of them from each problems. Okay. So let's solving 5b. The first one is test the divisibility of each of the following numbers by 2. Now, okay, so straightforward, we will check the digit at the units place or ones place, that is the rightmost digit, and see whether it is even or odd. So definitely I will put a cross mark if it is not divisible by the given number, that is 2, and a right sign if it is divisible by the given number, that is 2. So 94 is definitely divisible by 2, since the digit at the units place is 4, which is an even number, even digit. So that was part 1. Uh, 570 is of course divisible by 2 because the digit at the units place is 0, which is a even digit. Okay. 285 is not divisible by 2 because the last digit, the digit at the tens or ones place, the digit at the units place or ones place is 5, and 5 is an odd digit. It is not an even digit. Okay. 2, 3, 9, 8. It is simply divisible by 2. There is nothing to explain. So 5, 7, 9, 5, 3, 2. It is ending with the digit 2, which is an even digit. And 1, 3, 5, 7, 6. This is also divisible by 2 because it is ending with the digit 6, which is an even digit. 7, 4, 6, 8, 2, 1. This is not divisible by 2 because it is ending with the digit 1, which is an odd digit. 8, 4, 6, 6, 3. This is not divisible by 2 because it is ending with an odd digit, that is 3. And 9 is 6, 6, 6, 6, 9. This is not divisible by 2 because it is ending with the digit 9, which is an odd digit. Okay, so that was problem number 1. Problem number 2. Test the divisibility of each of the following numbers by 5. Now clearly we will check the rightmost digit, that is the digit at the units place. If it is 0 or 5, then the number will be divisible by 5. So I mean, there is really nothing to talk about, explain which one is divisible by 5 and which one is not. It is pretty straightforward. So let me list down the numbers which are divisible. So we have 95, we have 470. So I am listing down the numbers which are divisible by 5. 2, 7, 3, 5, 1, 2. This was 4. Okay. This was 4. And then we have 6, which is 3, 5, 7, 9, 0. Then we have 7, which is 9, 8, 7, 6, 5. And then we have 9, which is 7, 7, 9, 9, 0. So all these are the numbers which are divisible by 5. As you can see, all these numbers ends with the digit either 5 or 0. Okay. Let's do problem number 3. Test the divisibility of each of the following numbers by 10. So this is also pretty straightforward. We have to see whether the digit at the tens place is 0 or not. So I am listing down the numbers which are divisible by 10, and this is pretty straightforward. We have 90, we have 5, 7, 9, 3, 0, and then we have only 2 numbers are divisible by 10. Okay. Let's do problem number 4. Test the divisibility of each of the following numbers by 3. Okay. So 3, 83 For 83, we can see that 8 plus 3, a number is divisible by 3 when the sum of the digits of the number is divisible by 3. So 8 plus 3 is 11, not divisible by 3, not divisible by 3. So hence this is not divisible by 3. 2 is 378. Let's check. 3 plus 7, the sum of the digits is 3 plus 7 plus 8, which is equal to 18, and this is divisible by 3. 18 is divisible by 3. 18 is the sum of the digits of the number 378. Hence, the number 378 is divisible by 3. Now, it will really be waste of time if I try to solve all the problems. The concept is clear, and you just have to add the numbers, add the digits, and see whether it is divisible by 3 or not. Let's do three more. Let's say 9. 9 is 1 0 0 0 0 2. So definitely the sum of the digits will be 1 plus 2. This is equal to 3, and this is divisible by 3, and hence the given number is also divisible by 3. Let's do 8. 903164. The sum of the digits is 9 plus 3 plus 1 plus 6 plus 4. This is equal to 10, 10, 20, 23. 23 is not divisible by, 3. So the given number is not divisible by 3. Let's do the 7. 5 91282. The sum of the digits of the given number will be 5 plus 9 plus 1 plus 2 plus 8 plus 2. This equals 10. This is 10, this is 10, 20 and 27. So 27 is divisible. 27 is divisible by 3. So this number is divisible by 3. Okay. I won't do any other, I won't check any other numbers. Let's go to problem number 5. Test the divisibility of each of the following numbers by 9. So a number is divisible by 9. The same concept, the sum of the numbers should be, the sum of the digits of the given number should be divisible by 9. Let's do few of them. 327. The sum of the digits is 3 plus 2 plus 7 is equal to 12. Not divisible, 12 is not divisible by 9. 12 is not divisible by 9, hence the number is not divisible by 9. Let's do 3. The number is 32022. The sum of the digits of the given number will be 3 plus 2 plus 2 plus 2. This is equal to 6 plus 3 is 9. This is divisible by 9. Hence this number is divisible by 9. Let's do 6. 1 4 7 9 9. The sum of the digits is 1 plus 4 plus 7 plus 9 plus 9. This is equal to, this is 18, this is 19, and 19 plus 11, 19 plus 11 is 30. 30 is not divisible by 9. So this number is not divisible by 9. So I will not do the rest of the, I will not check the rest of the rest of the numbers. I hope the idea is clear. Now let's go to question number 6. Check the divisibility of each of the following numbers by 4. Okay. To check the divisibility by 4, we will check the last two digits, the numbers formed by the last two digits. If it is divisible by 4, then the number is divisible by 4. So 134, 134, these are the 34 is the number formed by the last two digits, and 34 is not divisible by 4. So it is not divisible by 4, as 34 not divisible by 4. Let's see, 2, 6, 1, 8. So the number formed by the last two digits is 18, and definitely 18 is not divisible by 4. The number formed by the last two digits is 18, and it is not divisible by 4. Hence, the number 618, 618 is not divisible by 4. Let's see 3, 3928. The number formed by the last two digits is 28, and obviously 28 is divisible by 4. So this number is divisible by 4. Divisible by 4. Okay, let's see 6, 5, 6, 7, 9, 4. The number formed by the last two digits is 94, and we have to see whether this is divisible by 4 or not. So this is not, 94 is not divisible by 4. Hence, the number is not divisible by 4. Okay, let's move on to question number 7. Test the divisibility of each of the following numbers by 8. Okay. So to check whether a given number is divisible by 8 or not, we have to see the number formed by the last three digits, whether it is divisible by 8 or not. 6132. The number formed by the last three digits is 132, and 132 is not divisible by 8. 132, this number 132 is not divisible by 8, so the number is not divisible by 8. Let's see 2. The number is 7304. So the number formed by the last three digits is 304, and we have to see whether this is divisible by 8 or not. 304. This is divisible by 304 is divisible by 8, as 304 is equal to 8 multiplied by 38. So this number is divisible by 8. Okay, let's see the number 3. It is 59312. So the number formed by the last three digits is 312, and is it divisible by 8 or not? We have to check that. 312. Yes, it is divisible by the number 312 is divisible by 8. Hence, the given number will be divisible by 8. Why? As we can see, 312 is equal to 8 multiplied by 39. is 39. So this number is divisible by 8. Let's do 9. The given number is 7350162. The number formed by the last 3 digits is 162, and we have to check whether this is divisible by 8 or not, and we can clearly see it is not divisible by 8. It is not divisible by 8. So this number is not divisible by 8. Okay, let's do problem number 8. Test the divisibility of each of the following numbers by 11. Okay, and now for 11, we have to be a little careful regarding the sum of the digits at odd places and sum of the digits at even places. It is better you can visually mark them if you need so. If you need to visually mark the digits at the odd places and the digit at the even places, you can do so. So the digits at the even places I am underlining with a single line, and the digits at the odd places I will underline with a double line. So these are the digits at the odd places, and these are the digits at the odd places, even places. So we have to check the sum or difference of sum of the digits at the odd places and the sum of the digits in the even places. So sum of the digits in the odd places is obviously, since all the digits are 2, 2 plus 2 plus 2, and minus the sum of the digits at the even places, which is 2 plus 2. This is equal to 6 minus 4. This is equal to 2. Now this difference, this number, this value has to be either 0 or divisible by 11. Then only we can say the number is divisible by 11. Now 2 is neither 0 nor it is divisible by 11. 2 not equals to 0 and not divisible, by 11. So this number is not divisible by 11. Let's see number 3. The given number is 3, 7, 9, 6, 5, 4. So mark the digits at the odd places with double underlines, and mark the digits with the mark the digits at the even places with a single line. So the difference will be 3 plus 9 plus 5 minus 7 plus 6 plus 4. This is equal to 17 minus 17, which is 0. Hence this number will obviously be divisible by 11, because the rule says that the difference of the sum of the digits at the odd places and the sum of the digits at the even places is either 0 or divisible by 11. Let's see the number 7. The number is 900163. Okay, so it is better if we write the number clearly so that we can mark the digits at the even and odd positions clearly. Okay, so this is the number. So we mark the digits at the odds and even places, and this, and this. Okay, so let's find the difference. It will be 9 plus 0 plus 6 minus 0 plus 1 plus 3. This is equal to 15 minus 4, which is 11, and this is divisible by 11. So the number is divisible by 11. Let's do another one. Uh, let's do the 8, number 8. The number is 7531622. Let's mark the digits. Okay. Now the difference will be 7 plus 3 plus 6 plus 2 minus 5 plus 1 plus 2. This is equal to 7 plus 3 is 10 and 8. 18 minus 8. This is equal to 10, and this 10 is not divisible by 11, and hence the number will not be divisible by 11. Okay, let's do problem number 9. This is regarding divisibility by 7. Okay. Test the divisibility of each of the following numbers by 7. Let's do the number 1, 693. Now 693, so what is the rule? The rule says subtract the number formed so the number formed by excluding the units digit is 69. From this number, subtract twice the units digit, that is 3 into 2. This is equal to 69 minus 6. This is equal to 63. This is, of course, 63 is divisible by 7. Divisible by 7. Hence, the number is divisible by 7. Let's see the number 2 is 7896. So this was the, let me mark the digit at the units place with a single line, and the number formed by the digits excluding the units digit is by a double line. Units digit in this number is 6, and the number formed by excluding the units digit is 789. So we have to compute 789 minus 6 into 2. This is equal to 789 minus 12. This is equal to 7 and 7. This is of course equal to 7 into 1 1 1. This number is divisible by 7. Divisible by 7. Hence, the given number is divisible by 7. I will do one more number. Let's do 7. The number is 98175. So the digit at the units place is 5, and the number formed by the digits excluding the units digit is 9817. So we have to see whether 9817 minus, we have to compute the value of this. This is equal to 9817 minus 10, which is equal to 9807. Now we have to see whether this number is divisible by 7 or not. Now, since this is a pretty big number, you can apply again the same rule for the number 9807. Now, if you can check whether this is divisible by 7 or not by doing a quick division, like will it divide by 7? Let me see. You can quickly check by the division method if whether this number 9807 is divisible by 7 or not. I have 1, and this is 2, this is 8, and I think it will be divisible by 7. So 1401. So 9807 is 1401 multiplied by 7. Okay. So this number is divisible by 7. So this number is divisible by 7. Now, if you are comfortable with doing a division, if this result turns out to be a big number, and if you are not that comfortable with doing division by 7 to check whether this number is divisible by 7 or not, you can apply the same rule again on the number 9807. So we have to, for example, I am not doing the I will not do the division by 7 to check whether 9807 is divisible by 7 or not. What I will do is I will again apply the rule on 9807. So 9807. So this is the unit digit, and the number formed by the digits excluding the unit digit is 980. So I will check whether 980 minus 7 into 2 is divisible by 7 or not. So this is 980 minus 14. This is equal to 966. Now whether this is so now this is a 3-digit number, which might be easy to now check whether this number 966 is divisible by 7 or not. Is it divisible by 7? It should be. So if I divide 966 by 7, I have 1, 26, I have 3, 21, and 8. Okay. So this way, if after finding the number, finding the value, that is the difference of the number formed by excluding the unit digit and the twice the unit digit, if that itself turns out to be a very big number, which is a little difficult or time consuming to check whether it is divisible by 7 or not, you can apply the same rule on that number. Okay, let's do problem number 10. Problem number 10 says find all possible values of x for which the number 7x3 is divisible by 3. We are given a 3-digit number 7x3 where x must be a digit. It could be digit anything between anything from 0 to 9, and we have to find all the values of x such that this 3-digit number will be divisible by 3. Now if this is divisible, my machine is giving my machine is running very slow. If this is divisible by 3 implies that the sum of the digits, that is 7 plus x plus 3, is divisible by 3. This implies 10 plus x should be is divisible by 3. Now what can the values of x be such that 10 plus x is divisible by 3? So this implies x is a digit, so anyway it will be either from 0 to 9. Now so what is the next number after 10 that is divisible by 3? That is 12. So x, if 10 plus x has to be 12, x will be 2. So x can be 2, and then x can be 5. Why I am getting 5? I will just add 3 to 2, and then x can be 8, and then that is x cannot be x, since x is a digit, it will be anyway from 0 to 9. So these are the values of x that will make, these are the possible values of x that will make the 3-digit number 7x3 divisible by 3, 258. Okay. Let's do question number 11. Find all possible values of y for which the number 5, 3, y, y1 are divisible by 3. Also find each such number. Okay, so in this problem 10 also, we were asked to find all the numbers. So the numbers will be obviously 7, 2, 3, 7, 5, 3 and 783. Now if this number 5, 3, y1 is divisible, will be divisible by 3, implies that the sum of the digits, that is 5 plus 3 plus y plus 1, is divisible by 3. This implies 9 plus y is divisible by 3. Now what can the values of y be such that 9 plus y is divisible by 3? Obviously y is a digit, that is it takes values from 0 to 9. So definitely y can have value 0, y can have value 3, y can have value 6 and y can have value 9. So these are the possible values of y which will make 9 plus y, the number 9 plus y, the value of 9 plus y divisible by 3, or these are the values of y which will make the 4-digit number 53y1 divisible by 3, and hence the numbers are 5, 3, 0, 1, 5, 3, 3, 1, 5, 3, 6, 1, 5, 3, 9, 1. These are the numbers. Okay. Let's solve problem number 12. Find the value of x for which the number x806 is divisible by 9. Also find the number. So the given number is a 4-digit number x806. We have to find the digit x such that this number is divisible by 9. So this will imply that the sum of the digits, that is x plus 8 plus 0 plus 6, is divisible by 9. This implies 14 plus x will be divisible by 9. Now what can the values of x be such that 14 plus x will be divisible by 9? So the least value of x that will make 14 plus x divisible by 9 is 4. So 4, and then we cannot have the next, we cannot have any more digits, because the next digit, rather not digit, the next number that need to be added to 14 to make it to make 14 plus x divisible by 9 will be x plus 4, that, or sorry, 4 plus 9. So 4 is the least number that when added to 14 plus x will make that when added to 14 will make 14 plus x divisible by 9. X, the least value of x is 4. The next value of x will be obviously 4 plus 9, but x is a digit. It has values from 0 to 9. So we have only one value of x, that is 4. So this implies the number is 4806. This is the number. Okay. Problem number 13. Find the value of z for which the number 471z8, the number given is a 5-digit number 471, z and 8. This number, we have to find the digit z such that this number, this 5-digit number, is divisible by 9. Also find the number. So we have is divisible by 9. So this will imply the sum of the digits has to be divisible by 9. That is 4 plus 7 plus 1 plus z plus 8 is divisible by 9. This implies that 4 plus 7 is 11, 12, 20 plus z is divisible by 9. Now what can the value of z be? And z is a digit, that is its value is from 0 to 9. So that 20 plus z will be divisible by 9. Now the least value uh, that will make 20 plus z divisible by 9 is obviously 7. 7. Now, uh, now we can have no more digits. So the only value of z, so the value of z is basically 7. This implies number is 4, 7, 1, 7, 8. Okay, let's do problem number 14. Give 5 examples of numbers, each one of which is divisible by 3 but not divisible by 9. Okay, so we have to find some numbers which is divisible by 3 but not divisible by 9. So now, so the numbers can be 6, because 6 is divisible by 3 and it is not divisible by 9. It could be 12. 12 is divisible by 3, it is not divisible by 9. It could be 24. Now these are 2-digit and 1-digit numbers. What about finding a 3-digit number which is divisible by 3 and not divisible by 9? So let's say I take the first 2 digits in random digits, let's say 4 and 5, 4 and 3, let's say 4 and 3. I'm trying to find the 3-digit number which is divisible by 3 and not divisible by 9. Now what will be the x, digit x? Let's say what can be the digit x at the units place such that these 3-digit number 43x will be divisible by 3 and not divisible by 9. Now 4 plus 3 is 7. So I can if I add 7, if x is 2, then 7 plus 2 is 9. 9 is divisible by 9. So we cannot take x as 2. So we can see that 4 plus 3 plus x is, we have to find x, the digit x, such that this sum, the sum of the digits is divisible by 3, and 4 plus 3 plus x is not divisible by 9. What can such x be? Definitely x is a digit. That is 7 plus x. 7 plus x is divisible by 3, and 7 plus x is not divisible by 9. We have to find such x. Now if x can be 8, because if x is 8, then 7 plus 8 becomes 15. 15 is divisible by 3, which is not divisible by 9. So one number can be 4, 3, 8, which is divisible by 3 and not divisible by 9. What else x can be? That is such that 7 plus x is divisible by 3 and 7 plus x is not divisible by 9. Obviously, if for x equals to 8, okay, 5. Oh, sorry, we could have also considered x as 5. So x, if we consider x as 5 as well as 8, then we can see that 7 plus 5 is 12. It is divisible by 3 and it is not divisible by 9. Also, 7 plus 8 is 15. It is divisible by 3. 7 plus 8 is 15. It is divisible by 3 and not divisible by 9. So I can have the 3-digit numbers like 438 and 435. These are divisible by 3 and not divisible by 9. Okay. Let's do problem number 15. Give 5 examples. How many examples? Give 5 examples of numbers. How many examples we found? Okay, we found 1, 2, 3, 4, 5. Okay. So give 5 examples of numbers, each one of which is divisible by 4 and not divisible by 8. Okay. So obviously 12 can be such number. Let's have three two-digit numbers which are divisible by 4 and not divisible by 8. So 12 is divisible by 4 and not divisible by 8. We can also have uh, 20. 20 is divisible by 4 and not divisible by 8. Okay. Also we can have, as you can see, from starting from 12, if you keep on adding 8, if you keep on adding 8, we are seeing numbers which are divisible by 4 but not divisible by 8. So 28, 36, all these numbers are divisible by 4 but not divisible by 8. If you consider three-digit number, let's say three-digit number. So for 4, we know that a number is divisible by 4 if the last two digits is divisible by 4. So let's say, okay, so what about three-digit numbers? Utilizing can we utilize these numbers to form a three-digit numbers which is divisible by 4 and not divisible by 8. To form a three-digit number, so let's say we are forming a three-digit number, x is the leftmost digit, and let's say we are trying to form a three-digit number x to 8 such that this number will not be divisible by 8 but it will be divisible by 4. As you can see, if I can take any digit in place of x, it will be divisible by 4 because we can see that the last two digits, which is 28, is already divisible by 4. So in place of x, if you take any digit, that number, three-digit number, will always be divisible by 4. But we have to choose x such that the three-digit number should not be divisible by 8. Now, if I take x equals to 1, it becomes 128, which will be divisible by 8. Mm, 56. We have to figure out one three-digit number. If we can figure out one three-digit number which is divisible by 4 and not divisible by 8, then we can keep on adding 8 to that number, and we will get numbers which will be divisible by 4 but not 8. Not divisible by 8. Five. Eight, 32, 6, 36, 52. Yeah, I think 612 is a three-digit number which is divisible by, of course, by 4, because the last two digits 12 is divisible by 4, but 612 is not divisible by 8. 8 7 56 52. Yeah, I think 612 is not divisible by 8. Now you just keep on adding 8 to it. You will get all these numbers are not divisible by 8. So we have found 1, 2, 3, 4, 5, 6, 7, 8, 8 such numbers. So this brings to an end of solving some selected problems of exercise 5B based on the tests of divisibility that we discussed in this video. I hope solving this problem and this video discussing the tests of divisibility by the numbers 2 to 11 of given numbers will help you in understanding the concepts of tests of divisibility. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The next video I will solve more interesting and illustrative problems which will be a little harder based on the same topic, that is tests of divisibility. I will solve 10 to 15 problems in the next video, that is part 4, so that you have a good practice of solving problems based on the concept of tests of divisibility. So please stay tuned for the next video, and thanks for watching, and until the next video, take care and bye.